We know that projectile particles are taking place their vital role in a nuclear reaction. If the energy of the projectile particle is less, nuclear reaction will not be taken place. Therefore, improving the energy of the projectile particle is a major task which could be arrived with the help of particle accelerators. Using a linear particle accelerator, we may get energy of the order of 10 MeV. Here is a simple linear particle accelerator. This is a vacuum tube. Inside the tube, so many cylindrical electrodes are present, and these electrodes are called drift tubes. The drift tubes are connected to a high frequency oscillator, so alternate tubes have potentials of opposite signs. Therefore, in a 1/2 cycle, when tubes 1 and 3 are positive, 2 and 4 will be negative. In the next half cycle, the polarities are reversed. 1 and 3 will be negative, 2 and 4 will be positive. Then the following assumptions are made while studying the working of this linear particle accelerator, which are: the ions are accelerated only at the gaps, not inside the tubes. Suppose a positive ion is moving inside the tube, its velocity is constant. And the second point is, if you talk about the length of these electrodes, the length of the first electrode is assumed as L, and the second electrode length is √2 times L, and the third electrode length is √3 times L. If this tube contains n number of electrodes, the length of the nth electrode is √10 times L. And the third important point is the time taken by the ion to cross the tube 1 should equal the time taken by the ion to cross the nth tube. Even though the length of the nth tube is more than that of the first tube, the time taken by the ion to cross both the tubes should be same. Now, without this working, suppose a positive ion leaves A and is accelerated during the half cycle when the drift tube 1 is negative concerning A. If the potential of the tube 1 is negative, it attracts the positive ion towards it. Therefore, the kinetic energy of the ion is half m v1 square. If v1 be the velocity of the ion when entering into the tube 1, half m v1 square, that should equal the charge of the ion into potential. From this, v1 is equal to 2 eV by m. The ions are accelerated in the gap between the tubes but travel with the same velocity inside the tubes. The length of tube 1 is so adjusted that as positive ions come out of it, the tube has a positive potential and the next tube 2 has a negative potential. Now, see this? If the potential of the tube 1 is negative, it attracts the positive ion. Once the positive ion has entered into the tube, it is moving with the constant velocity. When the positive ion comes out of the first tube, the polarity of the first tube is changed into positive. Automatically, the polarity of the second tube is converted into negative. If it is negative, then only the tube 2 will attract the positive ion towards it. Therefore, the acceleration is possible only at this gap. In this gap, the acceleration is possible. At this gap, the acceleration is possible. Now, half mv2 square is the kinetic energy of the ion when entering into the tube 2. That is equal to 2 times charge into potential. From this, V2 equal to root 2 times V1. This shows that V2 is root 2 times V1. The ion coming out of tube 2 may find tube 3 just negative and tube 2 is positive. See here, suppose the positive ion comes out of the second tube. The polarity of the tube 2 is changed into positive, whereas the polarity of the tube 3 is negative. If it is at the negative potential, then only it will absorb the positive ion towards it. Now the positive ion is accelerated towards the tube 3. If V3 be the velocity of the positive ion while entering into the tube 3, then the value of V3 is root 3 times the velocity at this tube 1. That means root 3 into V1. If the system is having n number of tubes, then the velocity of the ion on entering the nth tube is root n into V1. Now read out this. If n is the number of gaps that the ion travels in the accelerator and Vn is the final velocity acquired by it, then the velocity of the ion as it emerges out of the nth tube is Vn is equal to root n into 2 eV by m inside the root. Now the kinetic energy of the ion is half m Vn square, that is equal to half m n into 2 eV by m. If you simplify this, we can get neV. The final energy of the ion when they strike the target depends on the overall length of the accelerator. Only on the basis of overall length, number of tubes are included. That is the total number of gaps and the energy gained in each gap. So the energy of the ion depends upon the number of gaps existing inside the tube and the amount of energy gained in each gap. The limitation of the oscillator include maintaining a vacuum for a longer length, and the second one is the produced ion current is in the form of pulses. Therefore, their duration is short. To solve these two inconveniences, we may go for circular particle accelerators like cyclotron.